Now the first thing, poly means many atoms bonded together. You could think of these guys as just glued together. So the nitrogen and the 3 oxygens here, these guys want to stay together. The only catch is they can't do it unless they have one more electron than what they normally bring to the table. Nitrogen has 5 valence electrons, oxygens have 6 valence electrons each, but that's not enough to bond and stick together. They need to get one more electrons from somewhere, maybe from a sodium. So if they get that little electron, then these guys can all stick together and hang out as a package. So it's got to be one nitrogen bonded with 3 oxygens and that extra negative 1 electron. And where does it come from? Probably somebody who wants to get rid of 1 electron. Now over here we have a different situation. We have what we call sulfate. This is sulfur bonded with 4 oxygens, and they all want to hang together, but they don't have enough valence electrons, so they have to go get 2 from somewhere. So maybe they get them from a cation that's willing to give up 2, or maybe they get them from a cation that's willing to give up 3, but they only need 2 of them. So you'll see how this bonds, and it's not a 1-to-1 ratio because the 3 and the 2 don't cancel each other out. So we're going to need more aluminums and more sulfates, and it's going to go back and forth till we end up with a formula that looks like this. Oops, SO4 in parentheses with a 3 after it. So that'll be the formula when these two ultimately bond, but we'll walk through that in a second here. So what do you need to know? Polyatomics are many atoms. You could think of them glued together. They don't stay together unless they either get rid of or gain a couple extra electrons. And it's a very specific, unique formula that unfortunately for you, you're going to have to memorize. Now, there's crazy lists. This is a very small list compared to what's actually out there. Lots and lots and lots of polyatomics. The good news is, of this crazy list here, you're only going to have to know these 7. These 7 are the ones that are going to pop up the majority of the time. You will come across these this year, but these are the 7 that you're going to see over and over and over again. So you have to get a good handle on this. The sooner you can commit these to memory, the better. Now, let's just take a look at them quick and make some sense, because I know this looks a little overwhelming right now. Notice that we have nitrate and nitrite. Good news is we're only going to deal with the ates, ATE ending. We're not going to deal with the ites, but they're out there. Acetate, hydroxide, a little bit different ending, cyanide, but all the rest are 8, 8, 8, 8, 8, ite, 8, 8, 8, 8, ite, and then some weird ammonium here we'll talk about in a second. But the majority of them are ates or ites. There are 2 ides. Right here, there's a hydroxide and a cyanide. Most of them are ates or ites, but there are 2 ides, and those are both on your list, cyanide and hydroxide. Those are the 2 ides that you're going to have to know. But the rest are 8, 8, 8, and 8, and then that weird ammonium down at the bottom. So you have to remember 8, but know that ites exist and they're out there, but you don't have to memorize them. Okay, so if you look down this list, again, we have ates, ites, ates, 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 ites. They all have oxygen, don't they? Oxygen, oxygen, oxygen. This is a little exception here, but oxygen, 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 oxygen. You get the idea. So all these polyatomics have a certain nonmetal, or metal in some cases, bonded to an oxygen, or numerous oxygens. And they're all different numbers of oxygens. So that's where memorizing comes in. You just have to know that nitrate is 1 nitrogen and 3 oxygens. Sulfate is 1 sulfur and 4 oxygens. Carbonate is 1 carbon and 3 oxygens, and so forth. So you just kind of have to just spend some time memorizing them. Now, once you know your polyatomics, and somebody can say to you that sodium is bonding with nitrate, you should immediately know that nitrate is this, and sodium, of course, is Na+1. Now, how do we bond these? Well, you do it the same way you've been doing it before. You crisscross them. Take that 1, put it down here. Take the 1, put it here. Or recognize that it's already a 1-to-1 ratio. So it's just NaNO3. Nothing fancy. But what if it's not a 1-to-1 ratio? Aluminum with a +3 and sulfate, this is sulfate by the way, SO4 -2. Sulfate has a -2. It means it needs 2 electrons to stay together, and aluminum says, here, take 3. And aluminum says, I can't, I can only take 2, but I'll find some friends. So some sulfates are going to show up, and we're going to have to figure out how many aluminums bond with how many sulfates, because it's not a 1-to-1. So we do the same thing we've been doing before. We crisscross, and we'll figure out that ratio. Aluminum's got a +3, take that 3, put it here. Sulfate's a -2, put it there. So Al2, now SO4 with a 3. Now this could look a little tricky here. We got SO43, that doesn't make sense. We want to show that we need 3 sets of this big package that's glued together. So we're going to have to put the whole package, not in a circle, but in parentheses. So Al2 and then SO4 goes in parentheses with a 3. Anytime you write a formula and there's more than one of these polyatomics, you got to put it in parentheses. So basically, anytime you write a number after it, you put in parentheses. Because if you don't write a number after it, it means there's only one. No parentheses. But if you write a number after it, you got to put the polyatomic in parentheses. Not the nonmetal, or not the cation, just the polyatomic. So let's crisscross these guys here. The Mg's got a +2. This is hydroxide, -1. Crisscross them. The 1 goes here, and the 2 ends up after the hydroxide. Now, this is MgOH. If you're going to write a number here, which in this case we're going to put a 2, this automatically goes in parentheses. Now over here, we got a 1-to-1 ratio. I'm not going to write a number after the hydroxide. I'm just going to write mercury OH. I'm not putting a number here, so I don't have to put this in parentheses. It's only if you're going to write a number after it, then you put it in parentheses. So iron's making a +2, carbonate is making a -2. That's a 1-to-1 ratio. So I just write it as is, FeCO3. I'm not putting a number here, so I don't need parentheses. But if iron makes a +3, carbonate makes a -2, then I crisscross it. The 3 is going to go here, the 2 is going to go there. So it's Fe2CO3 is my carbonate. This is glued together. And then I want to put that 3 from the iron here. I'm going to put the 3 down here. So I'm going to put this in parentheses. Now let's take a look at what happens when we have a polyatomic ion out front. The NH4 has a +1 charge. The NO3 has a -1 charge. So this is a 1-to-1 ratio. NH4, NO3, not a single parentheses, because I didn't write any new numbers. 1-to-1. I'm not putting a number here and I'm not putting a number there, so no parentheses at all. Over here, the ammonium NH4 +1, it's the only +1 charge. That's hooking up with the phosphate. Ammonium says here, take 1. And phosphate says, but I need 3. So we need a different ratio. So we're going to put the NH4, remember the NH4 is all glued together, we're going to write the 3 from the phosphate after it. I don't want 43 H's and only 1 N. I want 3 sets of NH4. If you write a number after it, this goes in parentheses. So you're going to put the 3 here, and then the 1 from the NH4 goes after the phosphate. I don't write 1s. I'm not writing anything here, so I don't put this in parentheses. So I'm all set. Now let's look at the aluminum hooking up with phosphate. All right, so aluminum's +3, giving away 3 electrons. Phosphate says, that's perfect. That's exactly what I need. So the P and the 4 O's can stay together. This is a 1-to-1 ratio. So it's Al. I'm not going to write any numbers. PO4. PO4 are glued together, but I'm not writing any new numbers here. It'd be imaginary 1, imaginary 1. I'm not going to write those. So I don't need parentheses. It's just AlPO4. But copper is going to hook up with phosphate. Copper says, here, take 2. Phosphate says, but I need 3. So this ratio is not a 1-to-1. It's not going to work out nicely. So we need to crisscross the charges. 3 goes here, 2 goes there. Cu with the 3 from the phosphate. PO4 gets put in parentheses because I'm going to write a 2. The 2 from the copper goes down here. So I'm going to put that 2 there. If I write a number after polyatomic, I have to put it in parentheses. Cu3, PO4, 2. So don't go parentheses happy. Only put them next to, or around, I guess, a polyatomic ion if you're going to write a number after it. Never gets put around a plain old normal element from the periodic table. It's only used for polyatomic ions. Finally, let's write some names here. Now, sodium is going to hook up with sulfate. Over here, sodium's going to hook up with sulfide. Which is which? Well, anytime you see 8, you automatically know there's an oxygen bonded to something. You automatically know it's a polyatomic ion. So you either have to rack your brain because you memorize these, or you have to look them up for now. Sulfate's a SO4 with a -2 charge. Now sodium's right off the periodic table. Nothing fancy here. Na+1. Crisscross them, and then when you take this 1 and put it after the sulfate, and this 2 and put it down here, you end up with Na2SO4. Remember, I'm not writing that imaginary 1, so this doesn't go in parentheses. Now that's an 8 ending. That's a polyatomic ion. You're going to study sulfates in your list. You're going to remember that. But if you see sulfide, you look on the periodic table. Anytime you see ide, you look on the periodic table with the exception of 2, hydroxide and cyanide. All the rest, every other time you see ide, you look up on the periodic table. So on the periodic table, we get sodium +1. Sulfide is just normal sulfur becoming an ion, gaining 2 electrons. It's in group 6. Crisscross them, you get Na2S. Now, copper. Hey, look at that, Roman numeral. That's awesome, because I don't have to think about what charge this is. I automatically know copper makes a +2. Now, it's hooking up with nitride. Ide is on the periodic table, so it's N-3. Crisscross them, and it's Cu with a 3, N with a 2. No parentheses, because there's no polyatomic ions. Now, over here, I see a Roman numeral again. I love Roman numerals. Copper's +2. I don't even have to think. But now I see nitrate. Nitrate is not nitride. Nitride's on the periodic table. Nitrate is in your brain. You're going to study. You know that oxygen is bonded to nitrogen. We just have to know how many. That's where the studying comes in. NO3 with a -1 charge. So copper says, here, take 2. Nitrate says, nope, I only need 1, but I'll find a friend. So we crisscross them. We put the 2 there and the 1 there. Cu, imaginary 1. NO3, and I'm going to put a 2 after it. Anytime you write a number after a polyatomic ion, it goes in parentheses. So copper nitrate. All right, a couple more here. We're going to do iron with a Roman numeral 3, phosphide. So iron, again, love those Roman numerals, +3 charge. Phosphide is right off the periodic table. So you look up there, you find phosphorus in group 5, you say it needs to gain 3. Hey, that's a 1-to-1 ratio. FeP, all done. Over here, again, we see Roman numerals. Fe+3, phosphate. 8 tells you it's phosphorus with some amount of oxygens bonded to it. You don't know unless you study, but you're going to study, so it's PO4, -3. That's a 1-to-1 ratio too. FePO4. The P, the O, and the 4 are bonded together, but you're not writing any more numbers down here, so no parentheses. All right, almost done here. Aluminum. Al+3 hooks up with hydroxide. Now, ide usually means it's on the periodic table, like phosphide was on the periodic table. This is one of your exceptions. This ends in ide, but it's also not on the periodic table. This is an exception. These are your 2 exceptions you have to know. They end in ide, not 8, but they should be in your brain because you're going to study. OH, -1. So aluminum says, here, take my 3. Hydroxide says, I only need 1, but I'll find some friends. So we'll figure out the ratio here. So aluminum is going to end up with this imaginary 1 after it. Hydroxide is going to end up with a 3 after it. The 3 from the aluminum ends up after the hydroxide. So you're going to put a 3 there, so it's in parentheses because you're writing a number after a polyatomic. So it's aluminum hydroxide. And over here, mercury, hey, look at that, Roman numerals, love it. Hg+1, hooking up with cyanide. Cyanide needs to be in your brain soon. You're going to go study that. Cn-1. This is a 1-to-1 ratio. Mercury says, here, take 1. Cyanide says, perfect, I need 1. And they live happily ever after as a polyatomic ion compound. So, HgCN.